Good morning, students. Today we'll try to solve more numericals on miscellaneous exercise of integrals. So let us try another numerical. Previously we have solved 14 numericals. Now from 15 we'll try to solve. Now we have this question I have, that is miscellaneous exercise. Okay, this is miscellaneous exercise. So based on integral chapter class 12th mathematics. Now let us try to solve one more numerical we have. This is 17th numerical, f ax plus b, f of ax plus b whole n. Okay, so now let us try to solve this integral. Okay, what we can do, put f of ax plus b whole, no, only this much is equal to t. Okay, so now what I will get, f dash ax plus b into a dx is equal to dt. Now we can say f dash ax plus b dx is equal to dt upon a. So now what we can do is write here, that is 1 upon a is equal to, we will write here, t raised power n dt. Okay, so easily we can solve this numerical t n plus 1 upon n plus 1 plus c. Okay, so now what is t? We have taken f ax plus b n plus 1 plus c. Okay, simply we can solve the integral like this. Now let us try to solve the next one. Okay, so the next numerical I have, okay, let's try here itself. Now we have the question dx upon, we have the question, that is dx upon sine cube x. We have sine cube x, sine x plus alpha. Okay, we have sine x plus alpha. So now let us try to solve this. First of all, what we will do, we will try to apply the formula for sine x plus y, that is we have sine x cos alpha plus cos x sine alpha. Okay, so likewise we'll try to solve this. First we have applied the formula here. Okay, then this, okay, this is given in the root, so we have to take care of this also, that this thing is given in the root. Okay, now what we can do here is, we have applied that formula. Now multiply inside with the sine cube x. So I will get here dx upon sine just for 4x cos alpha plus sine cube x cos x sine alpha. Okay, this is what we have. Now what we can do here is, here we can multiply and divide by sine x in this. Okay, so what we'll get here, we'll get here what, sine power 4x cos alpha plus sine power 4x cos x sine alpha upon sine x. Okay, in this I have multiplied and divided by sine x. So sine x into sine cube x will be sine square 4x, and cos x upon sine x, it will become cot x. Let us try to solve here now. What will happen now, dx, we have to take care that it is in the root. Okay, now what we can do here is, what we will do here, we will write this sine is power 4x cos alpha plus sine is power 4x cot x sine alpha. Okay, so now what we'll do, we'll take sine 4x outside, we'll take common. So what will happen, I will have this sine 4x cos alpha plus cot x sin alpha. Okay, now my next step will be, I'll take this outside, so it will become sine square x dx. We have cos alpha plus cot x sin alpha. Okay, now this we have, now 1 upon sine square x is equal to, okay, we'll erase this. So now what will happen, we have, this will become cosec square x dx upon this much, we have cos alpha plus we have cot x, and here we have cot x and sin alpha. So now what we can do, put this as a t, put cos alpha plus cot x sin alpha is t, so that we got minus, we now here will see the integration of cot x, that will be log minus log cosec square x minus log cosec square x. Wait, we'll see first. Now we have, that is minus cosec square x. Okay, we are minus cosec square x sin alpha dx is equal to dt. So we'll take minus sign outside, sin alpha, and here we have dt upon root t. Okay, so this is what we have taken this. Now 1 upon root t, we all know t minus half plus 1 will be half, root t upon minus half plus, so it will be half. Okay, so here it is plus c, so you can write minus 2 upon sin alpha. Now what we have taken t here, cos alpha plus cot x sin alpha plus c. Okay, so likewise we able to solve the numericals. Now we have solved just two numericals. Now let us try to solve the next one. So now we have the next numerical. Now we have the third numerical in my hand, that is, now we'll try to solve this first. Third numerical now, that is 2 plus 2 sine 2x upon 1 plus cos 2x whole we have ex. Okay, now let us try. What we can do here is take 2 common. Okay, and what we can do here, we write 1 plus 2, no, instead of taking 2 common, 1 plus, what we can do here is, we'll try to solve 2 plus 4 sin x cos x. Okay, now here we can write 1 plus cos x, what will be 2 cos square x, 2 cos square x minus 1 is 1 cos 2x identity we have, so we'll apply now, that is 2 cos square x, we will write. Okay, so we have this. So now what we will do here, you can take 2 common, so we'll 1 plus 2 sin x cos x upon cos square x, because now we'll reduce it by 2. Okay, so we have applied the identity for sine 2x, that is 2 sin x cos x, and for the cos 2x, 1 plus cos 2x will be 2 cos square x. Okay, so now we'll separate it out. 1 plus cos square x plus 2 sin x cos x upon cos square x. Okay, now this we have, so it will be sec square x plus, it will reduce by, it will be to tan x. Okay, this is what we have. Now we can see in a very simple way we have okay, e raised power x dx, e raised power x, so dx. So now here it will be fx. So what we can do here is, in a very simple way, we know the formula, that is e raised power fx plus f dash x dx is e raised power fx. Here we have fx tan x, and differentiation of tan x will be sec square x. So this is fx, this is f dash x. So clearly we can write here e raised power fx tan x plus c. Okay, so like this we have the question that we can easily solve. Okay, it's only already, so 2 is there, so we'll take 2 common, we'll have this. Okay, sorry, the question is this, so we got this. Now it's clear. Now we have fx and f dash x will be sec square. So that is how we able to solve the numericals. We have solved just 3 numericals. Let us try to solve the 4th one now. Now the 4th one I have, the question is, what we can do here is, let's try to solve this one first. Okay, and this one we have, so now we'll try to solve. Now let us try to solve the 4th numerical. We have solved just 3 numericals. Now we'll try to solve the 4th one now. Now the 4th numerical I have, that is x square plus x. 4th now I will solve x square plus x plus 1 upon x plus 1 whole square x plus 2. So this numerical will be solved by using partial fraction now. So we can write this like this: a upon x plus 1 plus b upon x plus 1 whole square plus c upon x plus 2. So we'll get here a we have, so we'll try to solve x plus 1, x plus 2, plus b we have x plus 2, plus c will have x square plus 1 plus 2x, because here I have opened that square formula, a plus b whole square, we have a square plus b square plus 2ab, so I have applied this. Okay, so now I have this. Okay, so now we'll try to solve it out. Okay, so this is what we have here, and here we'll have only x plus 2. Okay, so now we have this x plus 1 and x plus 2. So now let us try to solve this. Well, first multiply inside x square plus 2x plus x plus 2, plus b we have x plus 2, plus c we have x square plus 2x plus 1. Now compare it and we'll be able to solve it. So what we have, a plus c is equal to 1. Okay, then no, first solve this. Add this plus 3x plus 2. Okay, plus we have this b x plus 2, and plus c we have x square plus 2x plus 1. Okay, so likewise now we can compare a plus c is equal to 1, then 3a plus b plus 2c plus 2c is equal to 1 and 2a plus 2b plus c is equal to 1. Okay, now let us try to solve this. What we can do here, we can multiply this equation by 2. Take this equation now. Well, third equation I have, so we'll try to solve this by multiplying with 2. So we get 6a plus 2b plus 4c is equal to 2. We have 2a plus 2b plus c is equal to 1. So we'll subtract. So what will happen? We'll get this 4a plus 3c is equal to 1. And this equation we have, this is fourth equation now, and this is first equation. So now let us try to solve this. 4a plus 3c is equal to 1 and 4a plus 4c is equal to 4. So we can easily find that is minus c is equal to minus 3. So I got therefore c is equal to 3. So therefore a is equal to what? Plus 3 minus 3. 1 minus 3 minus 2. So I got a and c. Now what I can do? I can put the value in here so that I can find the value of b. Okay. So we got 3a minus 6 plus b, and we have c is 3 na, plus 6 is equal to 1. So b is 1. Okay, so now I got the value. A I got here minus 2, b I got 1, c I got minus 3. Sorry, 3. Okay, so now let us try to put in this equation, that is the first one now. Okay, now let's try to solve. So now let us see how we can solve this by using the values we have. So we'll put here a we have minus 2. So we'll have dx upon, we have x plus 1, b we have 1. So dx upon x plus 1 whole square plus c we have 3. So we'll have dx upon x plus 2. Okay, now let's try to solve. We got minus 2 log x plus 1. Okay, here I will get plus 3 log x plus 2. And here what we will do now, we have square, so we'll take upper side. So minus 2 plus 1, it will be minus 1 upon minus 2 minus 1. So this is how we integrate. So we got minus 2 log x plus 1 minus, we'll have 1 upon x plus 1 plus 3 log x plus 2 plus c. Okay, so that is how we'll able to solve such kind of numericals. Today we have solved 4 numericals. Let us move on to the fifth one. So now let us try to solve this question first. I hope it's clear to everyone. So now we'll move on to the fifth numerical. Now let us try to solve the fifth one. Now we have the fifth one, that is x square plus 1. Okay, we have log x square plus 1 minus 2 log x upon x4 dx. We have this. Okay, this 2 log x, x4 this. So what we can do here, we can write like this: x square plus 1 upon x4, and here we'll write log x square plus 1 minus 2 log x. We have this. Okay, so now my next step will be x4. Now we'll take log x square plus 1 minus log x square with respect to x. So now what will happen? Log a minus log b, log a upon b. It will be as it is simple. So I will write log x square plus 1 upon x square. Okay. So my next step will be x square plus 1 upon x4. Now we'll solve log 1 plus 1 upon x square dx. Okay, I have just separated them. So we'll got this. Now here also I can do this. That is x square plus 1 upon, if I take x cube into x, so that will be easier for you, into log 1 plus 1 upon x square dx. Okay, so now what we can do here is just take 1 upon x3 here, and I can write x square plus 1 upon x square. Okay, so now it become easier for you, log 1 plus 1 upon x square dx. Okay, so now what I can do here is, we'll take the same thing here, 1 plus 1 upon x square. Okay, so now we'll have log 1 plus 1 upon x square dx. Okay, so likewise we can solve this numerical. Now what we can do here is, we'll try to take 1 plus 1 upon x square. Okay, so let's see what we can do here now. Now, well, what we do, we'll take this is equal to t, so that minus 2 upon x cube dx is equal to dt. Okay, so now we'll try to solve it here. Okay, so what will happen now? What will be there? 1 upon x cube dx, so it will be taken outside, minus half. So here it will be have root t, we have log t dt. Okay, so that is how we'll able to solve the numerical. Now what will we do? We have two things here. Okay, this is first one, and this is, we'll take first this, and this will be second function, and we'll try to solve it by parts. Okay, so what will happen? Minus half log t, integration of this will be integration of root t dt, minus differentiation of log t will be d by dt of log t integration of root t dt. Will solve it. Okay, so now we'll try to solve this. We'll get minus half log t, and we'll have t half plus 1 t 3 by 2 upon 3 by 2 minus log t, it differentiation 1 upon t into t 3 by 2 upon 3 by 2. Okay, integration of this log t, so we got this here. We'll integrate it again. So now what will happen? Let us try to solve it. Now what I got here is, that is 2 upon, okay, well, minus 2 upon 6 we have log t is power 3 by 2 minus, what we can do, if I reduce this 1, okay, 2 upon 3, so 3 by 2 minus 1, 3 by 2 minus 1, so it will be half, so root t dt. Okay, so now what we can do here, we can put the value minus 1 upon 3, t 3 by 2 log t minus 2 upon 3 half plus 1, got 3 by 2 upon 3 by 2, so I got minus 1 upon 3 t 3 by 2 log t minus 2 upon it will reduce out 3 by 2. What we can do, take 3 by 2 common, we'll have minus 1 upon 3 log t minus 1. Okay, we can take minus sign also common, so it will become plus. So now I can put value of t. For what we have taken, t is this first. So 1 plus 1 upon x square 1 upon 3 log 1 plus 1 upon x square plus 1. Okay, So that is how we able to solve the numerical. Let us try to solve the next numerical. Now we have solved today 5 numericals on this integration from miscellaneous exercise. Okay, for class 12th maths. Now let us try to solve the sixth numerical. So now let us try to solve the sixth numerical we have. Okay, so now we'll see, that is what we can do here. Write the question tan inverse. Sixth question today I have tan inverse 1 minus x upon 1 plus x. This is the question we have. 1 minus x upon 1 plus x dx. So now what we can do, put x is equal to cos theta. So what I got here is x is equal to cos theta. So we'll get minus sin theta d theta is equal to dx. So now we'll put here tan inverse 1 minus cos theta upon 1 plus cos theta. Okay. So now we have this cos into, we'll write this minus sin theta d theta. So now my next step will be, what we can do, take minus sign common and we'll write here tan inverse 2 sin square theta by 2 upon 2 cos square theta upon 2 into sin theta d theta. Okay, what we have done, we have used that identity. Cos 2 theta is equal to 2 cos square theta minus 1. We can take 1 minus cos 2 theta is equal to upon 2. Okay, we have here cos square theta. Okay, so now what this we can use. So I have used this identity for also cos 2 theta is equal to 1 minus 2 sin square theta. So we can take sin square theta is equal to 1 minus cos 2 theta upon 2. So here I have made changes according to it, so that we will easily solve this. What we have done, 1 minus cos theta I have reduced by 2 and multiplied 2 there. So I got this. So we have done. Now I got tan inverse tan theta by 2 into sin theta. Okay, minus 1 we have. So we have this. So now we're left with minus half here theta into sin theta d theta. Okay, let's start by parts. We can solve them. So we got minus half into theta into integration of sin will be minus cos theta minus integration, now difference of theta will be 1 or in sin theta will be minus cos theta d theta. So now we got theta by 2 cos theta plus sin theta plus c. So now we can put a value, but we have theta cos inverse x. Cos inverse x upon 2 into cos theta. Now we have cos inverse x. Okay, plus sin theta we have. So we'll put theta will be cos inverse x plus, we will not solve it to further. So likewise we can solve such kind of numericals. Now we'll try to solve the next one. Now let us try to solve the next numerical. Today we have solved only 6 numericals from miscellaneous exercise. Yesterday we have solved 14. So total 20 we have solved the numericals from the miscellaneous exercise. Okay, so now we'll try to solve the next one we have, that is 7th question. Today I am going to try to solve 1 minus root x upon 1 plus root x and whole this we have in root with respect to x. Okay, now what we can do here, put x is equal to cos square theta, so that we'll have here 1 minus cos theta upon 1 plus cos theta d theta here, and it will be in under root because x we have taken a cos square theta. So this plus here, now if I differentiate this, dx is equal to, it will be minus 2 sine theta, cos theta will be minus 2 into cos, this it will be. So I have to put here this also into minus 2 sine theta cos theta. So what we can do here? Well, take 2 outside, and here now I have 1 minus cos theta upon 1 plus cos theta into sine theta cos theta d theta. Okay, so now we'll try to solve this out. What will we do? 2 sine square theta by 2 upon 2 cos square theta by 2 inside, now into sine theta cos theta d theta. Okay, now what it will be? Minus 2 tan theta by 2 into sine theta cos theta d theta. Okay, now what I can write here? Minus 2 sine theta by 2 upon cos theta by 2 into sine theta cos theta d theta. Okay, so now what we can write here? Let's try to solve here. We have minus 2 outside, so sine theta by 2 upon cos theta by 2. What I can write here? Sine theta, I can write 2 sine theta by 2 cos theta by 2 into cos theta d theta. Why? What we have done? We know that sine 2 theta is equal to 2 sine theta cos theta. If I reduce it by 2, so I will get what? Sine theta is equal to 2 sine theta by 2 cos theta by 2. Okay, so that is how we have done this. Now this identity I have applied. What I can do? Take minus 4 common here. Okay, so now it will be reduced by this. Okay, so we have just reduced it. Now what will happen? Take 4 outside. So now I will have sine square theta by 2 into cos theta d theta. Okay, now I have this sine square theta by 2 cos theta d theta. We have minus 4 here. Now what we can do here? I have sine square theta by 2 sine square theta. So we have this. So now we can solve it out very easily. Okay, so like this. Now what we can do here? Put cos theta is equal to 2 cos square theta by 2 minus 1 into d theta. Okay, we all know the formula for the cos 2 theta. What we have? Cos 2 theta is equal to 2 cos square theta minus 1. But if I divide by 2, so I'll got 2 cos square theta by 2. So that is what we have used. Now we'll see what we can do here now. Now very simple question they have given in a very simple way. So now let us see what we can do here. Just multiply it inside, so we'll get minus 4. We got sine square theta by 2 cos square theta by 2. Okay, we have minus, now no, instead of box bracket we can use that one. So now 2 sine square theta by 2 cos square theta by 2 minus we have here sine square theta by 2. Okay, so finally I got this d theta. Okay, so now we have this. I've just multiplied inside sine square theta. So what we can do now? If I we can separate it out. If I take minus sign inside, so what I will got here, that is sin square theta by 2 d theta minus we have 2 sin square theta by 2 cos square theta by 2 d theta inside. We have now here only we have 4, so we'll multiply it later on. Okay, so now we have here sin square theta by 2 d theta minus 2 sin square theta by 2 cos what we have done here, just we have multiplied, no? So by 2. Okay, so now what we can do here, we have in a positive way and this is we have negative. Now what I can write, this is very simple way. If I try to now what I can write here, 1 minus cos, you have we have cos 2 theta is equal to 2 cos no that one for the sine, 1 minus 2 sin square theta by we have. Okay, so now if I am taking here, so cos theta is equal to 1 minus 2 sin square theta by 2. So we take this outside, so we'll have 1 minus cos theta by 2. Okay, so now we'll try to solve this first. We have, that is, here I will put that 1 minus cos theta by 2. Okay, so now I can integrate this very easily. Minus here, now this we have, if I write sin 2 theta is equal to 2 sin theta cos theta, okay, by 2. Now if I take 2, it will be this 2 sin theta cos theta by 2, but if sin theta, it will be sin square theta, sin square theta. Okay, so we have d theta, but here I have 2 inside. No, 2 is not there. Now I have solved this to sin square theta. Okay, so now it will become similar for me to solve this. Okay, so this. Now we'll try to integrate this. So we'll got 4 into theta by 2. Okay, 4 into theta by 2 cos 2 theta will have into what we can do, we can here will multiply inside minus 4 upon 2 and sin 2 theta by 2 plus here also theta by 2, so theta by 2 we have into 4 minus 4 upon 2 sin theta plus c. Okay, so by solving this we got it will be 2. Okay, so now here what we can do, put the value of theta. Okay, so now here we can put the value of theta. What we have taken here, we have taken the x is equal to cos square theta. Okay, we have taken the value of cos square theta, so it will be, now theta will be 4 into cos inverse x upon 2 minus by 2 we have, so sin 2 into theta, that is cos inverse x plus 2 into cos inverse x minus 2 sin cos inverse x plus c. Okay, so that is how we can easily solve the numerical. So we have solved today 7 numericals. Yesterday we have solved 14. So we have solved 21 numericals based on miscellaneous exercise for maths, that is class 12th. So now we'll try to solve next, that is on definite integrals. Okay.